Hello, so today we want to start the communication systems, and these communication systems are divided into two parts. One is analog, another is digital. And before going into the digital or analog communications, we first know what are the common terminology that will be used in analog or digital communications. So first, basically in communications, we are want to transmit our message signal to one end to another end. So we say the source which is producing the message signal, transmitter, and the destinations which receive the message signal, destination, and we also call it receiver, receiving end. So before sending the message from source to destinations, there is a lot of process involved, and we will explain this one by one. So first, the message which we want to transmit from source to destinations, we have to perform some operation into that so that it can travel the distance between the source and destinations, or we call it as a channel. So we will use the term MOPT for message signal, and we use TX for transmitting end and RX for receiving end. And the basic purpose of the communication system is to transmit message from source to destinations, and to perform or to send the message signal from source to destinations, we perform some operations which we call as a modulations. We will later see why the modulation is required. First we will understand what is modulations. So at the transmitting end, the message is converted to one form to another form so that it can be transmitted over channel, and we call it as the process. Uh, we call it as modulations. And at the this will happen at the source. Demodulations, this will happen at destination. This is the reverse of modulations. In modulation, we want to convert this message signal to another form so that we can transmit over the channel. And once we receive this modulated signal at the receiving end, we want to find out what the source want to transmit us, the source message. So we will demodulate at the end of receiver, and we will try to generate this message signal. So this is the whole purpose of this communication. And so while we are sending the message signal over channel, we must have to take some precaution, like this channel is, like if you are using air medium or wire, we can also use optical fiber, optical fibers, or etc. So this wire, air, and optical fiber is a channel is going to have some bandwidth, and the message that we want to transmit over this channel is also going to is also having some bandwidth. So for successful transmissions, the channel bandwidth must be more than this message signal bandwidth, otherwise it cannot cross. So you can imagine this using a simple example, like this is a pipe, and this is input, where water is going in, and from here the other end, this is source, and this is destination. So water is coming, and this is channel. So water is coming in from this end, and water is coming from this end. So we cannot we can send this water, if you want to say small amount like this, but we cannot transmit this amount of water from this small channel. So in this way you can correlate the message signal or channel bandwidth. Now we will check what is why the modulation is required, why we are changing the message signal to some another form while transmitting over the channel. So there are two major issue. If you do not require we will not use modulation, then we are going to face two problems. First, the height of antenna. So height of antenna is a function of wavelength. Suppose we want to transmit signals and without modulation, then the height of antenna is directly proportional to lambda by 4. So you can say height is equal to lambda by 4, and if you want to, if the wavelength is in, suppose 1 kilohertz, like 10 kilohertz, then what will be the height of antenna? 10 over 3 divided by 4, then this 2 5 2.5 into 10 to the power 3 meter. So this is not possible. We cannot, this is possible, but we cannot want a height of the antenna should be very large, otherwise this is not feasible, practically not feasible. And the second issue with this without modulation sending, suppose this is channel that we are having, and we have M1 message, M2 message, and M3 message, and we want to transmit at the same time to RX1, RX2, RX3 through the same channel. So what will happen? So what can happen, like the interference between this message signal will take place at the receiving inside this channel, and we will not be able to distinguish, or we will not be at the receiving end when we will try to regenerate this message. We are going to face some issue. What issue we are going to face? we will not be able to get the M1, M2, M3 message, because they are going to interfere with each others. So the message we will receive will not correct. So due to which we need modulations, because if the frequency this having frequency from 0 to 100, and this is having 50 to 100, and this is having frequency from 75 to 150, and then at the time you can see like this 0, 50, 100, 150, 200. Suppose this M1 is from 0 to 100. Like suppose this is M1 message, M1 of T. This is okay. 150. Let's make it 150. And this is M3 is from 75. So here we have 75 to 150. So here the interference will occur, due to which we cannot faithful reproduction of this message will not take place at the receiver, because they are our message signal are interfering with each other. So how we can avoid this? Suppose after modulations, if you use modulation and we shift these signals like here, and it's like M1 or M2, and this here is M3, not here, this is M3, M1, M2, M3. If after modulation we will send this message M1, M2, M3, then no interference will take place between these three signals, because there is a proper gap, or we can say this band gap. So after modulation there will be band gap, and there will be no interference between this message signal, so we can easily recover this message signal at the receiving end without any problems. And also, if you increase like in second case, if you decrease this wavelength and decrease this, then our height of antenna required will be also decrease. And how we will decrease this wavelength? By increasing this frequency. We will increase frequency, and I think you know the relation between frequency and wavelength. This, so wavelength is C by F. C is constant, 3 into 10 to the power 8 meter per second, and here is F. So we are using modulation so that we can increase this frequency, and when we will increase this frequency, the wavelength will decrease, and if this wavelength will decrease, then this height of antenna requirement will also decrease. So in this way we can say modulation is required for mainly two purpose.